In this video, we are going to solve all problems of AMC 12B 2023 before AMC 10A 12A 2023. I had released 4 free videos in algebra, number theory, geometry, combinatorics, and with more than 140 ideas and more than 45 homeworks. Many ideas of AMC 10A 12A 10B 12B 2023 are same. And we will work on them, which ideas are same, how to approach problems, and there are around 40-50 important background ideas and formulas in each topic: combinatorics, algebra, number theory, and geometry. If you want to learn them, feel free to send a message to my WhatsApp number in the description. Problem 1 of AMC 10B and 12B 2023. Mrs. Jones is pouring orange juice into 4 identical glasses for her 4 sons. She fills the first 3 glasses completely but runs out of juice when the 4th glass is only 1/3 full. What fraction of a glass must Mrs. Jones pour from each of the first 3 glasses into the 4th glass so that all 4 glasses will have the same amount of juice? Okay, so let's consider the first one is this, and okay, 1, 2, 3, 4, and the last part 1, 2, 3, and 4. Okay, and consider this one this. Okay, so at first, suppose for example here we consider for example the capacity of this is A. So we fill this one A, and this one A over 3. Without lots of generality, we can consider A equals 1. And then we want to reach 4 equal things, okay? Suppose each of them be X. First, we should see X is what? A plus A plus A, 3A plus A over 3 equals 4X. So if we consider common denominator, 9A plus A, 10A equals 4X. Now, if we divide both sides by 2, then 5A over 3 equals 2x. If we divide both sides by 2, 5A over 6 equals x. So here, each of them should be 5A over 6. Okay, all of them. Now, it says what? What fraction of a glass must Mrs. Jones pour from each of the first 3 glasses? So, we have A, we want to reach 5A over 6. So, A minus 5 A over 6 is the first one. We should reach, for example, this one to this one. So we should consider these parts. Okay, this part is the amount that we pour in the last box, for example, last glass. Okay, so A minus 5A over 6 is what? If we consider common denominator, 6A minus 5A, it will be A over 6, or 1/6 of each of these 3 glasses. Second problem of AMC 10B 12B 2023. Carlos went to a sports store to buy running shoes. Running shoes were on sale with price reduced by 20% on every pair of shoes. So if the first price, original price is P, then because of this discount, we should multiply it by 1 minus 20% after the discount. Then it says Carlos also knew that he had to pay a 7.5% sales tax on the discounted price. Okay, so it will be 1 plus, because it increases the price, 1 plus 7.5%. And it says he had $43. What is the original? Before discount means P, price of the most expensive shoes he could afford to buy. Okay, so this one should be equal to $43. Because he can pay this amount of money, and the maximum amount that he can pay is $43. Now let's consider 1 minus 20%. You can write it like this: 1 minus 0.2. 1 plus this is 1 plus 0.7. Let me write. We should divide this by 100, so it will be 75 equals 43. Okay, so it will be 1 minus 0.2 is 0.8. 1 plus that is 1.075 equals 43. Okay, now if we multiply, it will be what? 8 times 5, 40, we have 4. 8 times 7, 56, plus 4, 60, we have 6. 8 times 0, 0, plus 6, 6. 8 times 1, 8. 1, 2, 3, 4. 1, 2, 3, 4, like this, equals 43. Okay, now to get rid of these decimal digits, we multiply both sides by 100. So it will be p times 86 equals 43 times 100. Now, if you divide both sides by 43, if we simplify, it will be 2. If you divide both sides by 2, it will be 50. So the original price should be $50. It will be choice B. Third problem of AMC 10B and 12B 2023. The 3, 4, 5 right triangle is inscribed in circle A, and 5, 12, 13 right triangle is inscribed in circle B. What is the ratio of the area of circle A to the area of circle B? Okay, let's consider, for example, when we consider circle A, we have, for example, 3, 4, 5. So if we consider that like this, then it is 3, it is 4, it is 90. One idea is you should consider, basic idea, inscribed circle or inscribed angle. Here inscribed angle means what? Inscribed angle always is half of the arc. So when it is 90, this arc is 180. So we conclude that this will be, if we consider, for example, ABC, BC will be diameter because it is 180 half of the circle. So this one is center O. It is 3, 4, 5. So this one is 5, diameter is 5, so radius is 2.5, half of that. So we can conclude RA equals 2.5. Similarly here, the hypotenuse is 13, so diameter is 13. So RB is 13 over 2, which is 6.5. Okay, so here also we can write it 5 over 2 and 13 over 2. Now it says what is the ratio of the area of circle A to the area of circle B. Area of circle A is what? Pi RA squared over area of circle B, pi RB squared. So pi and pi will be cancelled. We can write RA over RB whole squared. RA is what? 5 over 2. RB is what? 13 over 2 squared. We can simplify and we can multiply both numerator and denominator by 2. So it will be 5 over 13 whole squared. So it will be 5 squared over 13 squared, which will be 25 over 169, which is choice D. Fourth problem of AMC 10B and 12B 2023. Jackson's paintbrush makes a narrow strip with a width of 6.5 millimeters. Jackson has enough paint to make a strip 25 meters long. So it will be something like this, for example. 6.5 millimeters and 25 meters. It says how many square centimeters of paper could Jackson cover with paint? Okay, we want to change the units. Change to square centimeters. So 6.5 millimeters, we should change it to centimeter. And if you want to change it to centimeter, it will be what? Each centimeter has 10 millimeters. So we should multiply by 10 to the negative 1. Why? Because look, let me tell you how you understand. You should multiply by 10 to the 1 or 10 to the negative 1. 1 millimeter is less than 1 centimeter. So you should multiply by its number less than 1 to change it to centimeter. Now, next one, 25 meters. Each meter has 100 centimeters. And each meter is greater than centimeters. So we should multiply by 100 to the 1. And here... okay, finished. Now, it will be what? 100. One of these will be cancelled. It will be 10. 10 times 6.5 is 65 times 25. Okay, 5 times 65 is 325 times 5 becomes 50. 25 as 5 times 5. And if you multiply it, it will be 25. We have 2. 5 times 2, 10 plus 2, 12. We have 1. 5 times 3, 15 plus 1, 16. So the answer is 1625, which is choice C. AMC 12B 2023 problem 5. You are playing a game. A 2x1 rectangle covers two adjacent squares oriented either horizontally or vertically of a 3x3 grid of squares. But you are not told which two squares are covered. Your goal is to find at least one square that is covered by the rectangle. A turn consists of you guessing a square, after which you are told whether that square is covered by the hidden rectangle. What is the minimum number of turns you need to ensure that at least one of your guess squares is covered by the rectangle? Okay. When you want to find minimum or maximum of something, the idea is to consider the range. And one part is for one side, you should find example. For the other side, you should prove. Here, which side is related to example? Because it says minimum, if you find it says you should ask this one. It is so much important. Pay attention, because if you don't pay attention to this, you will find the answer. Your answer will be one less than the real answer. It says you need to ensure that at least one of your guessed square is covered. So I should guess this one, and then I will see, okay, it will be covered. Because why? If it is no, then suppose this one is no, this one is no, this one is no. The only possible 1/2s are these things. All of them have a common cell, this one. So you can ask this one, and this one has to be yes. So answer is at most 4 or at least 4. At most 4. Because we found an algorithm, a strategy to reach the correct one, to reach the goal by 4 questions. Now, by 4 questions here, now I want to prove 3 is not possible. Okay, now let's prove how we can say the answer is at least 4. Suppose if by 3 questions we can find, for example, the correct cell, you should ask one cell from each row, because if you don't ask, for example, the first row, then maybe our 1/2 is in first row. Okay, and also if you want to reach the answer by 3, then you should ask mid one here. Okay, because if you ask only this one, maybe the 1/2 is here. If you want to reach, you should ask this one, this one, this one. But here we have problem, because we can say same thing for columns. Or we can say, okay, maybe 1/2 is this one or this one. So if answer is 3 or less than or equal 3, less than or equal 3 is not possible, because you should ask each row at least once. If answer is 3, you should ask mid cells of each row. Also similarly, you should ask mid cell of each column, which is not possible. Or you can say you should ask mid cell of each row. So you should ask like this, and then we have these things that you've not asked yet. So we prove the answer is also at least 4, so the answer is 4. If you want to solve this approach, is so much useful. Answer at least what, at most what. Okay, and before the exam, I released many videos in BMO, in AMC, that this idea was useful. If you want to know important ideas in combinatorics and other topics, feel free to send message to my WhatsApp number in the description. AMC 10B 2023 problem 12 and AMC 12B 2023 problem 6. When the roots of the polynomial p of x, x minus 1 to the 1, x minus 2 to the 2, x minus 3 to the 3, 2, x minus 10 to the 10, are removed from the real number line, what remains is the union of 11 disjoint open intervals on how many values of how many of these intervals is p of x positive. So let's see, it means what? It says when we remove, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The roots are these. We remove them. like this. Okay, how many intervals are left? Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's the reason here we have 11. It says on if you consider on these intervals, in how many of them p of x is positive. So first, we want to consider only important parts. For example, x minus 1 is important, but x minus 2 squared is always positive. Okay, so we can ignore that. So let's write only the parts that are important. X minus 1. X minus 3 cubed. We can say it is x minus 3 squared times x minus 3. So only x minus 3 is important. X minus 4 to the 4 not important. X minus 5 to the 5. The sign is equal to x minus 5 for the next one. X minus 6 to the 6 even. X minus 7 similarly. X minus 9. Only these parts are important. Okay. Now if you want to consider the sign, if we are here, then all of them will be positive because x is greater than 10, so greater than all of them. When we consider here, all of them again positive. When we go from here to here, only this one will change from positive to negative, okay? So it will be negative, negative. And then when we go from here to here, only sign of this part will change, so it will be plus, plus. For 5, only this one will change, negative 1, plus, plus, and negative 1 for this one. So in how many parts is p of x is positive? 1, 2, 3, 4, 5, 6. Okay? So it is 6. Somehow casework, but it was easier than, for example, hard casework problem. AMC 12B 2023 problem 7. For how many integers n does the expression square root of log n squared minus log n whole squared over log n minus 3 represent a real number where log denotes the base 10 logarithm. Okay. Before the exam, AMC 12, A10, A2023, I had released 4 videos. One related to algebra, and I said important rules of logarithm, and also the graph is what they can be useful here. The graph is like this is this one. When the base is greater than 1, it is ascending. It is log x, for example, to the base 10. So, because we have square root, inside square root should be at least 0. Okay? So, we should consider the sign of numerator and denominator. So, here, because n, it says n is integer, we know because here we use log n should be greater than equal 0. It's strictly greater than 0. So the first one that we can use is n1. So n should be positive integer. If n is 1, then let's consider this one a. A will be what? A will be square root of 0 minus 0 over 0 minus 3. It will be square root of 0 over negative 3, which will be square root of 0, which will be 0. It's a real number. So one answer is n1. Now, suppose n is at least 2. So because of here, as you can see, log n is positive. It's greater than 0. Now let's consider the sign of numerator and denominator here. Let's first focus on numerator. One rule in logarithm, I said the first one is this diagram I said before exam. And idea 2, again, I said before exam is log a, for example, to the m is m log a. So if you consider numerator, then this one will be 2 log n minus log n whole squared. And if you factor from log n, it will be 2 minus log n. We know this part is always positive, log n positive here, we proved. So 2 minus log n, we want to see under which case it is positive. If 2 minus log n is positive, then 2 is greater than log n, and by the definition of logarithm, we know that because it is increasing. So n is less than 10 because it is to the base 10, 10 squared or 100. Okay? So numerator, if n is less than 100, greater than equal to is positive for this n, and otherwise if n equals 100 it will be 0. If n is greater than 100 it will be negative. Okay, it was numerator. Now let's work on denominator. Log n minus 3, under which case it will be positive, so log n should be greater than 3 because log n to the base 10 is increasing, so n should be greater than 10 cubed by the definition of logarithm 1000. So denominator, it is positive if n is greater than 1000. It is 0, under which case it is 0, n equals 1000. It is negative if n is less than 1000. Okay, now let's check n from 2 to 100. So because square root, inside square root should be at least 0. This one is bad, n 1000, because denominator will be 0. And n 100 is good because inside square root will be 0. Here, positive, n should be between 2 and 1, less than 100, at least 2, less than 100, greater than 1000. It is not possible, because if a number is greater than 1000, it cannot be between 2 and 100. For this one, n is greater than 100, less than 1000. So we can have 101, 102 to 1000. 1000 strictly less than 1999. So it will be 999 minus 100. So it will be what? It will be 899. 899 plus n100, that was good, and n1, it will be 8. Answer will be 899 plus this case n100 and n1. So the answer will be 901. So the answer is which choice? The answer will be choice E. Okay, if you want to know other important formulas and rules in logarithm, or want to prepare for AME or other math exams, feel free to send message to my WhatsApp number in the description. AMC 12B 2023 problem 5. You are playing a game. A 2x1 rectangle covers 2 adjacent squares oriented either horizontally or vertically of a 3x3 grid of squares. But you are not told which 2 squares are covered. Your goal is to find at least one square that is covered by the rectangle. A turn consists of you guessing a square, after which you are told whether that square is covered by the hidden rectangle. What is the minimum number of turns you need to ensure that at least one of your guess squares is covered by the rectangle? Okay. When you want to find minimum or maximum of something, the idea is to consider the range. And one part is for one side, you should find example. For the other side, you should prove. Here, which side is related to example? Because it says minimum, if you find an example, a good example, the answer will be less than or equal that. This one side is related to proof. So, if you have a 3x3, let's cancel this one. Okay. You can check different cases, and for example, one thing is this. You can ask this one, if it is yes, okay, by one question. If it is yes by one question, maybe no. If it is yes, you will find. If no, then you see this square satisfies, but it says you should ask this one. It is so much important. Pay attention, because if you don't pay attention to this, you will find the answer. Your answer will be one less than the real answer. It says you need to ensure that at least one of your guessed square is covered. So I should guess this one, and then I will see, okay, it will be covered. Because why? If it is no, then suppose this one is no, this one is no, this one is no. The only possible 1/2s are these things. All of them have a common cell, this one. So you can ask this one, and this one has to be yes. So answer is at most 4 or at least 4. At most 4, because we found an algorithm, a strategy to reach the correct one, to reach the goal by 4 questions. Now, and by 4 questions here, now I want to prove 3 is not possible. Okay, now let's prove how we can say the answer is at least 4. Suppose if by 3 questions we can find, for example, the correct cell, you should ask one cell from each row, because if you don't ask, for example, the first row, then maybe our 1/2 is in first row. Okay, and also if you want to reach the answer by 3, then you should ask mid one here. Okay, because if you ask only this one, maybe the 1/2 is here. If you want to reach, you should ask this one, this one, this one. But here we have problem, because we can say same thing for columns. Or we can say, okay, maybe 1/2 is this one or this one. So if answer is 3 or less than or equal 3, less than or equal 3 is not possible, because you should ask each row at least once. If answer is 3, you should ask mid cells of each row. Also, similarly, you should ask mid cell of each column, which is not possible. Or you can say you should ask mid cell of each row. So you should ask like this, and then we have these things that you've not asked yet. So we prove the answer is also at least 4, so the answer is 4. If you want to solve this approach, is so much useful. Answer at least what, at most what. Okay, and before the exam, I released many videos in BMO, in AMC, that this idea was useful. If you want to know important ideas in combinatorics and other topics, feel free to send message to my WhatsApp number in the description. AMC 10B problem 13 and 12B problem 9 of 2023. It says, what is the area of the region in the coordinate plane defined by absolute value of x minus 1 plus absolute value of y minus 1 less than or equal 1. Okay, if you consider this, if you change, for example, xy to minus xy minus x minus y, or x and negative y in all quadrants, we will reach same result. So we can only consider this in first quadrant and then at the end multiply by 4, because we will have same figure, similar figure in other quadrants. So we can consider x and y are at least 0. So it will be what? X, my absolute value of x will be x. So absolute value of x minus 1 plus absolute value of y minus 1 is less than or equal 1. First, let me tell you, absolute value of x plus absolute value of y less than or equal 1 is what? If you want to draw this, you will see that if you can consider 4 cases again. For example, if we consider x and y greater than or equal 0, if here, we want to consider this part first. If x and y greater than or equal 0, in this problem, it is a different thing, idea 1. Okay, this graph will be what? If x and y greater than or equal 0, so it will be x plus y, at most 1. So it will be this part. 1, 2, 1. And now, because again, if you change xy to negative xy, or negative x negative y, or x negative y, we can consider first quadrant, and we have 4 similar things. Negative 1, negative 1. Okay, so it will be a square. With what length? The side is root 2. The center is 0, 0. Now here, x minus 1 by minus 1. Okay, so the center instead of 0 will be what? Will be 1, 1. Okay, you should shift this 1 unit to right, 1 unit to up. Now it will be what? It will be this graph. If I draw something like this. Okay. So again, it will be a square with side length root 2, and the area here is what? Root 2, root 2. The area will be root 2 times root 2, which will be 2. Now we have similar things you can draw. You can draw here. We have similar thing. And you can also check for next other quadrant. We have same thing. 2, 2 here also 2, 2. So the answer, as I said in the beginning of the solution, is 4 times 2 equals 8. And we saw before AMC exam, we saw some problems related to drawing diagram like this. And all of them, in all of these problems, you should draw concentric quadrants and solve problem like this. So the answer will be choice B. AMC 12B 2023 problem 10. In the xy plane, a circle of radius 4 with center on the positive x-axis is tangent to the y-axis at the origin. Okay, let's draw this circle. Let me first draw this one, Ctrl X. Now, let's consider like this one. Then it says this circle with center of radius 4 with center on the positive x-axis, which is tangent to the y-axis at the origin. So because the radius is 4, so we know the center is on 4, 0. Now next one, and a circle of radius 10 with center on the positive y-axis tangent to the x-axis at the origin. Okay, so it will be something like this. Okay, so because the radius is 10, it will be 10. Now, if we connect these 2 points, and it says what is the slope of the line passing through the 2 points at which these circles intersect. Okay, so it is, for example, O. This one is A. The problem wants slope of OA is what? Now, we know that OA, this center, O1, O2. Let's consider this one, O1, O2. O1, O2 is perpendicular bisector of OA. Okay, and before exam, I had released AMC 10A, 12A, 2023. I had released 4 videos, one of them in geometry, coordinate geometry, and I said, for example, many important rules, distance of a point from a line, and other things. One of them was this: if 2 lines are perpendicular, the product of their slopes will be -1. Okay, now slope of OA is what? We don't know, we want to calculate. O1, O2 is what? For example, this point, 10, 0, O2 is 0, 10, and O1 is 4, 0. Okay, so it will be 10 minus 0, again, another formula, idea 1. Idea 2 here is to find slope 10 minus 0, 0 minus 4 equals 1. So SOA times 10 over -4. Which will be -5 over, the product is, sorry, let me write -1. 10 over -4 is -5 over 2. The product is -1. So S of OA is what? 2 over 5. If you write 2 over 5 times -5 over 2 will be -1. So the answer is choice E, problem 10. If you want to learn similar ideas in coordinate geometry, prepare for AME or next AMC or USOMO, IMO, feel free to send message on my WhatsApp number in the description. AMC 12B 2023 problem 11. What is the maximum area of an isosceles trapezoid that has legs of length 1 and one base twice as long as the other? Okay. So we can consider our trapezoid is similar to this one. Okay, before exam, I had released a video. In geometry also I had released 3 other videos for combinatorics, algebra, number theory. In that one I said, when you see a trapezoid, draw altitude. Also especially in isosceles trapezoids. If we draw altitudes like this, the problem says legs of length 1, so 1, 1, and One base twice as long as the other. So if it is x, this one is 2x. Okay? This one is 2x, so this one is x. These two things are equal. Because of isosceles trapezoid, these two triangles are congruent. So x over 2, x over 2. And if you consider this height as h, so area of, let's call this one, area of ABCD, we want to calculate in terms of x. Area of ABCD, the area of trapezoid, you can write it as a formula, is h times sum of the bases, x plus 2x over 2. But h is what? By Pythagorean theorem, h squared plus x squared over 4, this one in triangle, for example, AED. H squared plus x squared over 4 is 1. So h squared is 1 minus x squared over 4. So we can say h is the square root of 1 minus x squared over 4. Okay, so it will be 1/2 times square root of 1 minus x squared over 4 times x plus 2x, 3x. Okay, we should find maximum of this, which will be, let me write 3 over 2 times x times the square root of 1 minus x squared over 4. Because we have x over 2 and something like this, I define a as x over 2. Okay, so x is 2a. So area of ABCD in terms of a will be what? 2a over 2 is a, so 3a square root of 1 minus x squared over 4 will be a squared, 1 minus a squared. So we should find maximum of this. One way is using derivatives, but we want to solve it with, for example, the QM, AM, GM, something like this. Again, before exam, I had released a video in algebra, and in that problem, last problem of 25 of AMC 10 of some year, it was we had two roots and we wanted to find maximum or minimum of something. Then I said 3-4 solutions about that. I want to use one of them that is similar to that. We know QM is greater than equal quadratic mean, is greater than equal arithmetic mean, greater than equal geometric mean, greater than equal harmonic mean, and greater than equal minimum, less than equal maximum of elements. So quadratic mean is what? A squared plus b squared over 2 square root of that. It is QM. AM arithmetic mean a plus b over 2 for two variables. Also, we have similar things for n variables. Square root of ab greater than equal 2 over 1 over a plus 1 over b. Now here, because I have this, I want to use this one and this one. QM GM. By QM GM, I can say square root of a times, let me tell you, by QM GM, we know that square root of a squared plus b squared over 2. Also, we can use, let's use QM GM. We can say it is greater than equal square root of ab. You can raise both sides to the power of 2 because here they are positive. And here, in general, we say, okay, when we use these inequality, we use for positive real numbers. For negative, we should check is it correct or not. Here, if you raise to the power of 2 a squared plus b squared over 2 greater than equal ab. Now I want to use this here. A times this, I consider here a, let me write it with other color, like this one, a, b, if I want to use, is less than or equal 3 times. 3 is because of this. A squared plus b squared over 2. This is squared plus this 1 squared, which is 1 minus a squared over 2. We can cancel these two things, so it will be 3 over 2. Okay, and equality holds when in all of these things when the terms are equal. When a equals 1 minus a squared, let's see, is it possible? If you raise to the power of the a squared equals 1 minus a squared, so 2a squared equals 1. And then we can conclude a equals 1 over root 2 or root 2 over 2. Okay, and our maximum area will be 3 over 2. When a equals root 2 over 2. Okay, so the answer will be 3 over 2, choice D. If you want to learn similar ideas, idea 1, idea 2 here, idea 3, these inequalities, if you want to, for some Cauchy-Schwarz inequality, and Chebyshev's inequality. If you want to learn important inequalities and other things in algebra and other topics that are useful in AMC, AME, USAMO, USA, JMO, IMO, feel free to send message to our WhatsApp number in the description. AMC 12B 2023 problem 12. For complex numbers u equals a plus bi and v equals c plus di, where I equals square root of -1, define the binary operation. This symbol v equals ac plus bdi. Suppose z is a complex number such that z, for example, cross z equals z squared plus 40. What is length of z? So we consider z equals a plus bi. Then by the definition of the problem, z cross z equals what? A squared plus b squared I. Now here, if I write this equation, a squared plus b squared I equals z squared, which is a plus bi whole squared, plus 40. So this one will be a squared plus bi squared, which is negative b squared, plus 2abi plus 40. Okay, when two complex numbers are equal, their imaginary parts are equal, their real parts also are equal. So real parts is a squared minus b squared 40. So a squared equals a squared minus b squared plus 40. Imaginary part here, b squared here, 2ab. Okay, now here we can cancel a squared. So if we take negative b squared to left hand side, b squared is 40. So b cannot be 0 because here b is not 0. We can divide both sides by b. B is 2a. So if we raise... Okay, so because we want to find length of z is what? Is the square root of a squared plus b squared. We have a b squared, so if we raise here both sides to the power of 2b squared is 4a squared. B squared is 40. So if you divide both sides by 4, so a squared is 10. Okay. Now, b squared plus a squared is what? Is a squared is 10. B squared is 40. So it will be square root of 50. So we know it is equal to 5 times 5 times 2. 50. So it will be 5 times square root of 2. So the answer is E. Okay, here we've not used any special things. Sometimes we should use polar form and other thing if you want to learn important ideas in algebra, in complex numbers, and other things. Feel free to send message to my WhatsApp number in the description. This is problem 17 of 10b and 13 of 12b. It says a rectangular box B has distinct edge, length A, B, and C. Okay. So if we draw, it will be something like this. For example, this one. This, and this. Okay. So it is, for example, A, and this one is A, this one B, B, and this one C, and this one C. Okay, it says the sum of length of all 12 edges of P is 13. So how many A's, for example, are there? 1, 2, 3, 4. 4 A's, 4 B's, 4 C's. So 4 times A plus B plus C equals 12. Equals 13. This. The sum of the areas of all 6 faces is 11 over 2. So AB, this face, front and back. So 2 times AB plus BC, top and bottom, plus AC, right and left, equals 11 over 2. And the volume is 1 over 2. Volume is what? ABC. ABC is 1 over 2. And then it wants the longest interior diagonal connecting two vertices of P. Okay. So first we want to find ABC, and for this one we should use the idea I had told you before exam, Vieta's formula. Okay, if we have, for example, ax cubed plus bx squared plus cx plus d equals 0, then if the roots are r1, r2, r3, r1 plus r2 plus r3 is negative b over a. And the proof is not hard. You can write it as a times x minus r1, x minus r2, and x minus r3, and then consider related coefficients, then you can prove it is this r1, r2 for general polynomial degree n. We have Vieta's formula, r1, r3 plus r2, r3 equals c over a, and r1, r2, r3, for example, constant term, is negative d over a. Now, I want to write a polynomial that the roots are a, b, c. Okay, so for writing that, first I simplify a plus b plus c is what? Is 13 over 4. AB plus BC plus AC is what? 11 over 4. And ABC is what? 1 over 2. Also, I had released a problem related to SMT Stanford Math Tournament. In that problem, we had two roots and we used same formula. So the idea of this problem, we had this formula we have in SMT, Stanford Math Tournament, Harvard, MIT Math Tournament, and other exams. Okay, now let's define a polynomial that satisfies Vieta's formula. I say x cubed, sum of the roots negative b over a. So I say negative 13 over 4 x squared. Okay, so sum of the roots will be what? Negative this, 13 over 4. For this one, I write plus 11 over 4x, and for last one, negative 1 half equals 0. Now, I multiply this by 4, it will be 4x cubed minus 13x squared plus 11x minus 2 equals 0. Second idea that is useful, idea 1, idea 2, when the degree is greater than equal 3. If degree is 2, you can use polynomial, you can use quadratic formula. If the degree is at least 3, try to find at least one root by plugging different values. Try to find at least one root, then you can factorize at least one root. Check plus minus 1, 0, plus minus 2, and so on. Here, if you check 1, if x is 1, then it will be 4 minus 13 plus 11 minus 2. 4 minus 13 is negative 9, 11 minus 2 is plus 9, 0. So because x1 is one root, you can factor from x minus 1, you can factorize. One factor is x minus 1. Now let's create this. I want to create 4x cubed, so I place 4x squared. It will be what? 4x cubed minus 4x squared. So I want to reach negative 13x squared, so I place negative 9x. So I have negative 9x squared, then we will have negative 13x squared minus 9x times minus 1 plus 9x. I want to reach 11x, so I place plus 2. So it will be plus 2x minus 2. It will be exactly this. 0. Now for this one, we can use quadratic formula or you can factorize. Okay, both of them are possible. So let's factorize. I prefer to factorize. I write 4x and here x. So 4x squared. 2. I should place 1, negative 1, negative 2. Negative 2 for here. Negative 8x. Negative x, negative 9x equals 0. So the roots are what? 1, 2, and this one 0, 1 over 4. So A, B, C are these values without loss of generality. We can consider, for example, A is 1, B is 2, C is 1 over 4. Now, if you want to find longest diagonal, it will be like this one, okay? And the formula is, you can draw this one, it will be b squared. Let me call this one x, we want to find x. This one is y. Or let's consider, because we had xw, this one, for example, is y. We know y is, w squared is what? Is a squared plus y squared. Y by Pythagorean theorem. Y squared is what? Is b squared plus c squared. We can call it as idea, will be idea 3, I think, yes. Idea 3, the length of longest interior diagonal of the cuboid here. So the answer will be square root of a squared plus b squared plus c squared. So it will be 1 plus 2 squared 4 plus 1 over 4 squared 1 over 16. So if we use common denominator 16, 1 plus 4, 5 times 16, 80 plus 1, 81. If we consider square root, it will be 9 over 4. So the answer is 9 over 4. Before exam, I said I had released video in algebra, combinatorics, geometry, and number theory, and I explained Vieta's formula. If you want to learn how to approach problems like this, how to solve problems related to Vieta's formula and other topics, feel free to send message my WhatsApp number in the description. AMC 12B 2023, problem 14. For how many ordered pairs A and B of integers does the polynomial x cubed plus ax squared plus bx plus 6 have 3 distinct integer roots? Okay, so then we can conclude x cubed plus ax squared plus bx plus 6 equals x minus r1, x minus r2, x minus r3. For this problem, again, we should use Vieta's formula, and in my video before AMC 2023 in algebra, I've solved some problems related to Vieta's formula, and for other exams, if you want to work on background ideas, feel free to send message to my WhatsApp number in the description and comments. Okay, here R1, R2, R3 will be negative 6. You can also consider, you can prove it by considering related coefficients. R1, R2 plus R1, R3 plus R2, R3 equals B. R1 plus R2 plus R3 equals A. Now we should work on this equality. Because R1, R2, R3 equals negative 6, so if we consider only 6, one root should be 6, the other ones 1, 1 or 3, 2, 1. Now let's consider the sign. We should have 1 negative 1 or 3 negative 1s, because the problem says distinct. R1, R2, R3 are distinct. Here we cannot have 3 negative 1s, then both of them will be negative. If you have 1 negative 1, this one cannot be negative 1. So the only case is 1 negative 1, 1 1, and 1 6. Okay. For this case, so one case here. For this one, because the roots are negative, are distinct, we can select one of them as negative. So 3 cases and all of them negative. 1 case, so 4 cases. 4 cases plus 1 case equals 5. Okay, and for each of them, A and B will be different, because if for 2 cases, for 2 cases here, A and B be same, then we have problem, because the roots should be also same. But we've considered 5 cases, and in all these 5 cases, we have different roots. So the answer is 5. If you want some more problems like this, or want to prepare for AME, upcoming AME, next AMC, USAMO, USA, JMO, IMO, I want to work on important background ideas, feel free to send message to my WhatsApp number in the description. Okay. Problem 18 of 10B and 12B, problem 15. It says, suppose that A, B, C are positive integers such that A over 14 plus B over 15 equals C over 210. Which of the following statements are necessarily true? Like when we are working with integers, for example, A, B, C that are in, for example, positive integers or integers, we don't like denominator. Okay, so when we have, for example, this multiplied by 8. So here, because we have 14, 15, and 210, I want to get rid of denominator. So I should multiply both sides by what? 210, because 210 is 14 times 15. So it will be 15a plus 14b equals c. Now let's read the statements. If it says if GCD of a and 14 is 1, or b and 15 is 1, or both, then GCD of c and 210 is 1. There's statements that, so let me explain first. Look, for example, GCD of a and 14, if it is not 1, for example, means what? Let's consider this case first. If GCD of a and 14 is not 1, for example, suppose a is an even number, 2q. then GCD of A and 14 is at least 2. So this one will be what? Even. Multiple of 2. This one is even, so C has to be even. Okay? So if A and 14, if they have a common prime, the common factor, then left side will be multiple of that factor. So C should be also multiple of that factor. Understood? Okay. So now by this point, for example, I want to say third one is correct. If GCD of C and 210 is 1, if and only if GCD of A and 14 is 1, because if GCD of A and 14 is not 1, then we have problem. Like this. For example, A is even, then A is 2Q, B 2Q, then C is 2Q. So also B and 15, 1. If we have these things, again, we have same thing. Why? Because, so from here to here, we proved by contradiction. Because we said, for example, if it is not 1, then like this, we reach contradiction. Similarly for this one. This one is correct. From right to left. Again, I want to use contradiction. For example, suppose C and 210 is not 1. Without loss of generality, C and 210, they have a common factor, like 2. So if, for example, GCD of C and 210 is not 1, without loss of generality, for example, suppose C is, for example, 3K. Okay, so C is 3K, that prime, one of them, has that prime, like this. This one is multiple of 3, 15. So multiple of 3, multiple of 3. So 14b also multiple of 3. Because if you take it to right side, right hand side will be multiple of 3 because this and this, both of them are multiple of 3. So 14b multiple of 3. So b should be multiple of 3. But here we've considered that GCD of b and 15 is 1. Okay, so by the same way you can reach contradiction. So this part is correct. So third condition is correct. Now I want to prove second condition. It says if GCD of C and 210 is 1, then we know both of them. The GCD of both of them equals 1. It says this one is 1 or this one is 1 or both. This or and, for example, it is logic. It is related to logic. When we say this one or this one, because we know both of them should be 1. So it says then this one 1 or this one 1 or both of them. This or means this one or both of them. Because we know both of them is 1, it will be correct. Okay? So, it was related to logic. If you had any question about these things, you can send message to my WhatsApp number. And for first one, it says if GCD of A and 14 is 1 or B and 15 is 1 or both, then GCD of C and 210 is 1. No. I try to find a case that it satisfies this one, for example, one of them, but it doesn't satisfy the next one. So let's find 15a is 1. When we want to say one condition is right, we should find a counter example, 210. Okay, it says GCD of A and 14 is 1, B and 15 is 1, or both, then GCD of C and 210 is 1. I'm sorry, here it's C. Let me tell you a counter example. I will explain again second one why it is correct by logic and the table, true-false tables. So here, for example, I want to find a thing that it says if GCD of A and 14 or this or both of them is 1, then this GCD is 1. So I select A, for example, equal to, let's consider 7Q. Then left side will be what? 7 times 15Q plus 2B equals C. Okay. Okay, then I consider, for example, B is, or let's find an easier way. The first one, 7, I want to find counter example. This GCD is not 1, but B and 15 is 1, so we consider B 1. Then C will be what? 15 times 7 is 105 plus 14 will be what? 119, which is 7 times 17. So we know GCD of C and 210 is not 1, So it says if we satisfy this one, we know A, B, and 15 is 1, because B is 1. It satisfies assumption because it says or, but it doesn't satisfy the sentence. So it is a contradiction counterexample. Let me explain second one by true false. Here, for example, it is PQ, P or Q. True true, true false, false true, and false false. In first three cases, it will be true true true. Last one false. So when it says if GCD of CN 210 is 1, we know both of them will be 1. It says, okay, this one or both. So it will be like this, P or Q. When both of them equals 1, true, true, then P or Q also will be true. By this assumption, let's consider this one as idea 2, true-false tables. It's good to consider P and Q and P, then Q. We have these things related. Let me tell you P. Let me complete this table for you to be able to use. Or and are so much easy in logic. We have one more thing, P then Q, P and Q. This one will be true, all other three will be false. PQ is one true, this one false, this one true, this one true. It is the definition, okay? But we can find some, for example, logics, some problems related to logics that, for example, help, and those problems help you to understand these things better. But it is definition in logic. Okay, you should memorize these things, and it helps you to solve this one. If you want to solve related problems, and now the correct choice is what? This one. Okay, if you want to learn problems in logics, want to solve more problems in combinatorics, or other topics, feel free to send message to my WhatsApp number in the description. AMC 12B 2023 problem 16. In the state of Coinland, coins have values of 6, 10, and 15 cents. Suppose X is the value in cents of the most expensive item in Coinland that cannot be purchased using these coins with exact change. What is the sum of the digits of X? Okay, so 6 and 10, if we consider 6 and 10, we can create 6 by using 6 and 10. Let's see, we can create what first? We can create 6, then we can create 10, we can create 12, 6 plus 6. 14, we cannot create that. 16, we can create 6 plus 10. Then we can create 18, 6 plus 6 plus 6, 20 with 10 plus 10. And then 22, 10 plus 20. Okay, so then we can say 10 plus 6. For 24, we can say 4 sixes. Okay, for 26, 16 plus 10. From here, we have all even numbers. 26 plus 10. Then from 18, 28. And 20 plus 10, 30. 22 plus 10, 32. 24 plus 10, 34. 36, and so on. We have all even numbers. Okay? And now, as you can see, from this part, we have all even numbers. Now, if we add 15 to each of them, we have 31, 33, 35, and so on. So, because we have also 30 here, from here, we have all odd numbers. From here, we have all even numbers. So, we can say that we can create 30, 31, 32, 33. From 33, we can create all numbers. Because if you add 15 to each of them, look here, this one 15, if we use coin 15 cents, then we can create all numbers from 30. And let me tell you something. When you want to find minimum or maximum of something here, for example, most expensive, again, the idea is to consider range. Answer is at least what, at most what. One part is with example, one part is related to proof. Here, because we want to find maximum one, when we consider what, let's focus on this problem now. From 30, we can create this. So here, answer is at least or at most what? We can say answer is at most 29. Okay? By this proof. Now, I want to see, can I create 29 or not? If I cannot create 29, then I can say the answer is also 29. Okay. 6x plus 10y plus 15z. Suppose 6x plus 10y plus 15z equals 29. I want to reach contradiction, okay? 6, 10, 15. Now here we can say it is, can we consider even? Here it is even, here it is even, odd. So this one also should be odd. One thing. So even this one is odd. So 15z should be also odd. So the only possible case, so z should be odd. So if z is 2, then it will be, if z, for example, is 3 or greater than that, then we have problem, because then x and y should be negative. So the only possible z is 1. So 6x plus 10y plus 15 equals 29. So we can subtract 15 from both sides. 6x plus 10y equals 14. Now we can divide both sides by 2. So 3x plus 5y equals 7. And because x and y are at least 0, y cannot be 0, then 3x 7, y cannot be 2 or greater than that. So the only possible case for y is 1, 5, and let me check. So if we place y equals 1, for x we don't have any cases. Also, if you place 0, you don't have any case. If you place 2, it will be 5 times 2, 10x negative. Okay, so we proved that 29 is not possible. So we've concluded that the answer is 29. Okay, so and it says, what is the sum of the digits of x? X is 29. Sum of the digits of x is 2 plus 9, 11. If you want to solve similar problems like this, and for example, also they are related to Bizaut's theorem, related to number theory. If you want to solve similar problems, feel free to send message to my WhatsApp number in the description. AMC 12B 2023, problem 17. 3 side lengths of a triangle are in arithmetic progression with shortest side of length 6. Okay, so it will be 6. The sides are 6, 6 plus d and 6 plus 2d. Because 6 is the minimum one, and d should be positive or greater than equal 0. Okay? And we can say greater than 0. One of the interior angles measures 120 degree. So it will be like, for example, this one. Then here, for example, 225. And 120 will be 345. It will be something like this. Okay? It will be this. So this angle is 120 because we know that it will be the largest side because opposite to largest angle. So this one is 6 plus 2d. One of them is 6 plus d and the other one d. 6. Okay, now we want to find area of the triangle. If we find d, then we can find the triangle and we have all sides of triangle and we can calculate area by the formula 1/2 times this side times sine of 120. Okay. Now here we should use cosine law before exam. I said in all years we have cosine law, Pythagorean theorem, sometimes double Pythagorean theorem. If you want to know important ideas also in AME and USAMO, feel free to send message to my WhatsApp number in the description. Okay, by cosine law we know a squared equals b squared plus c squared minus 2bc cosine a. And here if we use that, 6 plus 2d whole squared equals 6 squared plus 6 plus b squared minus 2 times 6 plus d cosine 120 degree. So 6 squared is 36, 2d squared is 4d squared, plus 2 times 2 times 6, 24. D equals 36 plus 36 plus 12d plus d squared. Cosine 120 is negative cosine 60, which is negative 1 half, negative 1 half, and negative 2 will be cancelled. It will be plus 1. It will be plus 6 times this plus 36 plus 6d. Okay, now we want to find d. We can cancel. We can subtract d squared from both sides. Then we have 3d squared, 24d, 12d, 6d. So it's 12d minus 60 plus 6d. Then 36 we can cancel. 36, 72. We can take it to left hand side, negative 72, 0. And then we can divide both sides by 3. It will be d squared plus 2d minus 24 equals 0. And then we can use quadratic formula or we can factorize. db equals 0, then negative plus 6 minus 4. Minus 24, 6 minus 4, 2. So d can be negative 6, or this one is 0, or this one is 0, because the product is 0. So d can be negative 6 or 4. Negative 6 is not possible, so d is 4. Now because d is 4, we can write the sides. Here 6, 6 plus 4, 10. So the area of ABC. Now we should use idea 2, the area of ABC. Before exam, I said some important things, Heron's formula and also other form of Heron's formula when we have squares in the geometry video I had released before AMC 10A 2023, 10A 12A. 1/2, you can say BC sine A. It is equal to 1/2 times 6 times 10 times sine 120. So it will be 1/2 times, we can simplify. 263, so it will be 30 times sine 120, which is sine 60, which is root 3 over 2. So if you simplify, it will be 15 root 3. So the area is 15 root 3, which is choice E. Okay, choice. If you want to solve similar problems or prepare for any math exam, Amy USAML, or other exam, you can send message to my WhatsApp number. AMC 12B 2023. Problem 18. Last academic year, Yolanda and Zelda took different courses that didn't necessarily administer the same number of quizzes during each of the 2 semesters. Yolanda's average on all the quizzes she took during the first semester was 3 points higher than Zelda's average on all the quizzes she took during the first semester. So, if you consider Yolanda and Zelda here, for example, it is Z, this one is Z plus 3. 3 points higher. And then it says Yolanda's average on all the quizzes she took during the second semester was 18 points higher than her average for the first semester. So it will be this plus 18, Z plus 3 plus 18, which is Z plus 21. And was again 3 points higher than Zelda's average on all the quizzes Zelda took during her second semester. So 3 more than this. So this one minus 3 is Z plus 18. Which one of the following statements cannot possibly be true? So let's check the choices. Choice A. And it says Yolanda's quiz average for the academic year was 22 points higher than Zelda's. Okay. So we know for Yolanda it was first semester, second one, and for academic part, we know it is at least Z plus 3, at most Z plus 21. Okay, and for Zelda, the average is at least Z, at most Z plus 18. Now we know it says the difference, so it is Yolanda's quiz average for the academic year was 22 points higher. The maximum is z plus 21, and the minimum for this one z. So it can be at most 21 greater than this. So choice A is not possibly true, so the answer is A. But let's check also other choices to see how we can reject. We should find counterexample for each of them. B. Zelda's quiz average for the academic year was higher than Yolanda's. Okay, so for choice B, y z plus 3, z plus 21 for Zelda. For Zelda, here z plus 80. So if you want that the academic average be greater than this one, so from here we should have a lot of things. For example, 9 from this, 1 from this here, 1 from 9 from this, 1 from this, and without loss of general to consider z is 0 in this case. So academic average of, let's consider this one AY, this one AZ. Academic average AY will be what? Will be 9 times 3, because z is 3, 9, z is 0, 9 times 3, plus 1 times 21, over 10, it will be average, it will be 27 plus 21, 48 over 10, 4.8, and average of Zelanda, also you can consider z is 1, again you will reach same result. So it will be 1 times 0, 9 times 18, 9 times 18 over 10. So it was what for y, for we had 3, 3, 9 threes for first semester, and 121. And for Zelanda, 1, 0, and 9, 18 for second semester. Okay, 9, 18 over 10 is what? Is 9 times 8, 72. We have 7, 9 times 1 plus 7 is 16 over 10. So it will be what? 16.2. So it is possible that academic average for Zelda is greater than Yolanda. And here, so we can reject B for C. Now let's check C. It says Yolanda's quiz average for the academic year was 3 points higher than Zelda's. Okay, so C. Let me write this other color. For C, if we have 1 from this and 1 from this, here 1 from this, 1 from this. So, and Z, for example, equals what? Equals 1. So AY will be what? AY will be 3 points higher. 1 plus 3, 4, plus 22 over 2 is 26 over 2, 30. AZ equals what? 1 plus 19 over 2, 20 over 10, and 20 over 2, 10. So AY, Yolanda's quiz average for academic year was 3 here, 13, 3 more than 10. Okay, so it is possible. C. Now let's check D. Let's write it with green. Zelda's quiz average for the academic year equaled Yolanda's. Okay, so Y, let me copy these parts. We want to reach equal part. So, for example, here, we can consider without loss of generality, for example, Z0 or Z1. For example, Z0. Then it will be 3, it will be 21, it will be 0, it will be 18. I want to reach same average. So here, for example, suppose we have some zeros, some 18s. Okay? And for example, suppose we have 1, 0, 1, 18. Okay, and the average is 9. I want to reach 9 with 3 and 12. So I want to see how many 3, for example, A plus 21B over A plus B equals 9. So then 3A plus 21B equals 9A plus 9B. So 9a minus 3a, 6a, 21b minus 9b is 12b. So b should be 2, a should be 2b. Okay, so we should have 1, b was this one. So b, for example, 121 and 2 3s. Okay, 24, 27 over 3, 9. Okay, we've reached same average. We can find lots of examples. Last one. If Zelda had scored 3 points higher on each quiz she took, then she would have had the same average for the academic year as Yolanda. Okay, if all of them be 3 more, the average will be 3 more. And at the end, it says would have had the same average for the academic year as Yolanda. Okay, so which of them was 3 less than that? Choice C. Okay, so if instead of 1 it takes 4 and instead of 19, 22, 3 more 26 over 2, it will be 13. Okay, so it is possible. So the answer is choice A. Okay, if you want to solve similar problems or want to work on important ideas, feel free to send message on my WhatsApp number in the description. Problem 21 of 10B and 19 of 12B, AMC 2023. It says each of 2023 balls is randomly placed into one of 3 bins. Which of the following is closest to the probability that each of the bins will contain an odd number of balls? Okay, when you see problems like this a bit harder than other problems, I said the most useful idea is what? Before the exam, considering small examples, okay? Before exam, I released a video in combinatorics part 4 videos. In combinatorics part, I said considering small examples so much important, and now here if you want to apply, at first we have 2023, so if you have 1 ball, it will be what? Number of good cases 0. We cannot have odd. If we consider n3, so all cases will be what? 3 cubed. Okay, because we have 3 balls, each of them 3 cases. For example, ball 1, ball 2, ball 3. And good cases will be what? Each of them should be odd, so we should have 1 in each of them. Good case will be this. So the first one 3 cases, next one 2 cases, and 1 cases. So 6 cases. So bad cases will be what? Here 27, 21. Okay. And we don't have for n2 and for example 4 is not possible, because when I want to have odd, all of them be odd plus odd is odd. So number of balls should be odd. So next small case that we should check is what? n5. Okay. Now let me tell you something. Here I try to find a way to calculate it in terms of 3. I say what? If we place 1 to 3, then we reach a good case or bad case. If it is good case, then we have odd. If we had bad case, then only 1 case is possible. 3 odds. When you place 3, 1, 2, 3. So for example, look 1, 2, 3, 4, 5. I've placed 1, 2, 3, so all of them are odd, or 2 even, 1 odd. Okay. So here, how many cases are there? 6. Here, how many cases are there? 21. Now, for 4 and 5, in this case, you have 3 options. Both of them should be in 1 bin. So it will be, because I want to reach odd at the end. So 6 times 3. For this one, we should multiply by what? 4 and 5. 4, 5 here or 5, 4 here to change these 2 evens to 2 odds. So 21 times 2. Okay, it will be 18, 42. So the sum is what? Sum is 60. Okay, now let's calculate for general n. I say an is what? Number of ways and on. If I want to calculate probability, so 60 good cases here, all will be what? 3 to the 5. Good cases will be what? Will be 60. And bad cases will be what? 3 to the 5 minus 60. 3 to the 5 is 3 times 81, which is 243. 243 minus 60 will be 183. Okay, so in general, if you want to say the same thing, A, and suppose for example we call it A5, we call it A3, good cases. Okay, or let's because there are good cases, let's consider G. So it will be G3, good cases, G5. Now I want to calculate Gn. I say, okay, Gn minus 2, good cases for n minus 2, odd, odd, odd. I should multiply by 3. Because when you want to place other two balls, you have 3 options. First one, both of them. First one, second one, or third. Plus. That cases equal to what? 3 to the n minus 2 minus Gn minus 2. It will be like this. Then we have 2 options for balls n minus 1 and n minus 2. Now, if it's simplified, 3 times Gn minus 2 minus 2 times Gn minus 2 will be Gn minus 2 plus 2 times 3 to the n minus 2. Now I want to use telescoping rule. Idea 1, idea 2. Also in AMC 10, before AMC 10A, I had released a video in combinatorics, and I explained telescoping rule also for AMC 10A. 2022 and 2023, I released solutions of 2 problems, and I said telescoping rule is important. Again, here we have same idea. That's the reason that you should learn background ideas. Okay, let's calculate. Okay, I write Gn minus 2. We've defined for odd numbers. That's the reason Gn is defined in terms of Gn minus 2. Now if we, instead of n, we replace n with n minus 2, with Gn minus 2 minus Gn minus 4, 2 times 3 times n minus 4. And Gn minus 4, for example, minus Gn minus 6 equals 2 times 3 to the n minus 6. And up to G5 minus G3 equals 2 times here for n minus 2, for 5, 3 to the 5 minus 2, which is 3 cubed. G3 is what? 6. Now, if we add all these numbers, here Gn minus G3 equals 2 times 3 cubed. Next one will be 3 to the 5, odd numbers, 2, 3 to the n minus 2. G3, we've calculated G3 here. G3 was what? G3 was 6. Okay? So we can write G3 as 2 times 3. So if we take it to right side, it will be 2 times 3 to the 1 plus 3 cubed to 3 to the n minus 2. And now I factor from 3 again here. So 2 times 3, 6. It will be 1 plus 3 squared plus 3 to the 4 to 3 to the n minus 2. Again, before AMC 10, A 2023, I released a video and I said important identities. One of them was this, 1 plus R2. Some of them were useful in 10A 2023, this one useful in this exam. R to the n plus 1 minus 1, R minus 1. I want to use this identity here. But here, as you can see, it is R1, R2, but here the powers are even. So I do what? I can say 9. 9 squared now. It will be exactly like this, plus 9 to the n minus 2 over 2. And now, if I use this formula, it will be 9 to the n minus 2 over 2. Here, sorry. Here, when we factor from 3, it will be n minus 3. Okay? So it will be n minus 3 over 2. So 9 to the power of n minus 3 over 2 plus 1, which is n minus 1 over 2 minus 1, 9 minus 1. 9 minus 1 is 8. We can simplify this one. Divide this one by 2. And 8 by 2 is 4. So it will be 3 over 4. 9 to the n minus 1 over 2 minus 1. So we can say Gn equals 3 over 4. Now we can write 9 is 3 squared. So it will be 3 to the n minus 1 minus 1. Okay, so we have this value for Gn. Now the problem says find probability for 2023. So we should find G 2023 over all cases in 2023, which is 3 to the 2023. Now, if you replace here, it will be 3 over 4, 3 to the 2022, minus 1 over 3 to the 2023. So it will be what? 3 times 3, let me write 3 to the 2023 over 4, minus 3 over 4 over 3 to the 2023, which will be the first one. 1 over 4 minus 1 over 4 times, if we cancel these 3 by these, 3 to the 2022. And the problem doesn't want exact answer. It says what? It says it is closest to which choice. So as you can see, if you want to approximate, this one is so much small. So it will be equal to 1 over 4 approximately. And the answer will be choice E. So I had told you many ideas in the 4 videos I had released before the exam. If you want to learn other ideas like this for AME, if you want to prepare for AME, use some more other exam. As I said before, feel free to send message to my WhatsApp number in the description. AMC 12B 2023, problem 20. Cyrus the frog sits on a flat surface. He jumps landing 2 feet away. So, for example, we can consider this part. Or let's consider this one. He then chooses a direction at random and again jumps 2 feet. Okay, what is the probability that after the second jump, Cyrus lands within 1 foot of his starting position? Okay, so without loss of generality, we can consider the first jump is this one, 2 units. Now, we consider, for example, this one is 2, and we want to find the probability that this length, for example, D is less than or equal 1. Okay, so it is 2. It's not important that D is less than, probability that D is less than or equal 1 in general equals probability that D is less than 1. Okay, let's calculate here. If you want to calculate this, we know that this angle can be from the direction. The direction is important, from 0 to 360. Okay, so let's consider this angle alpha. Then I draw a perpendicular here. And I know this is alpha over 2. Okay. And this one is D over 2. Okay. So we want to see, for example, because we know when we increase, for example, when we increase this angle to 180, the distance D will be larger and larger. Okay, so it is increasing to 180. Why? Because look, it will be like this. Distance will be increasing, then again it will be decreasing. Okay, so here, suppose, for example, it is 1. Let's consider first it is 1. Let's see what happens. Okay, so if it is 1, this one is 1. So this one will be 1/2 because it is isosceles triangle. This one 1/2. I want to find this angle. Okay, suppose it is theta. We know sine theta will be what? Will be 1/2 over 2, which will be 1 over 4. Okay, so now let's consider this angle, alpha. If alpha is greater than or equal to theta, then it will be good, less than or equal 180. Okay, and we have similar thing for this part, so we should only focus on this part. And because the problem, the choices are related to pi, in radians they are. So we can write, for example, alpha less than or equal pi, greater than or equal to theta, this angle. Theta will be what from here? It will be arc sine 1 over 4. Okay. Now, I know if alpha is greater than or equal to arc sine 1 over 4. If it is greater, the problem says d less than or equal what? 1. So alpha should be greater than or equal 0. That's right, greater than or equal 0. Less than or equal to theta. Okay, 2 arc sine 1/4. So now we say, okay, from 0 to this part is good. All cases will be what? Pi. So it will be 2 arc sine 1/4. If you want to consider the whole part, also we have same thing here. So you should multiply this one by 2 and this one by 2 pi. Okay, again, it will be cancelled and the answer will be 2 arc sine 1/4, 1/4 over pi. So the answer will be E. Okay, if you want to solve similar problems, combination of combinatorics and geometry, and also in USAMA we have, in IMO we have, AME we have. If you want to work on these problems and background ideas, feel free to send message to my WhatsApp number in the description. AMC 12B 2023. A lampshade is made in the form of the lateral surface of the frostum of a right circular cone. The height of the frostum is 3√3 inches. Its top diameter is 6 inches and its bottom diameter is 12 inches. A bug is at the bottom of the lampshade and there is a glob of honey on the top edge of the lampshade at the spot furthest from the bug. The bug wants to crawl to the honey, but it must stay on the surface of the lampshade. What is the length in inches of its shortest path to the honey? Okay. For this one, we should continue to create the complete cone. Okay, so let me draw. It will be like this one, and this one, and we can consider. Okay. Okay, let's move it to y. Okay, it will be something like this one. And it says what? At first, you should know how we can create a cone. Okay, if you're going to create a cone, we should consider, for example, this part and remove a sector of that, a sector of this circle, and for example, you remove this one, then by this part you can create a cone. Okay, it is so much important that you know how to create a cone. Now we consider this center will be here. And now we know we have another part. For example, here it is our bug. And I want to consider in which part we have honey. So it will be some point like this. Okay. Opposite point here. Honey. So now let's draw altitudes. Okay. And also I want to use Thay's theorem or similar triangles. It says the diameter here is 6, so it will be 3. Here it will be 6, because the diameter is 12. Here is 3√3. And this over this is 3/6. So this part, 3/6 is 1/2. This part is half of this part. So we can conclude this part equals this part, and also this part equals this part. So this part will be also 3√3. Now if we write Pythagorean theorem, 9 plus 27 is 36. So this length is 6. This length is 6. So OB is 6. Okay. Now we want to unfold this. Let me tell you this cone. So I want to see the angle here is what. I know that this perimeter, because when you fold this length will be stick to this length. So we know that this part equals this perimeter, which is 12 pi. Okay, so this part is 12 pi, and the radius is what here? It is OB. So it will be 12. Now, the perimeter of this circle is what? 2 pi r, which is 24 pi. Because it is 12 pi, we can conclude, okay, it is semicircle. Now it is so much easier to work with. It will be a circle like this. And we consider only semicircle. Okay. Now it is our O. So our exact figure is this. It is B, but now honey is what? If you pay attention, here for example we call it H prime. Okay, H prime is is opposite to this one. Okay, if you consider B and H prime will be half of the whole part. Whole part here is this, so half of that exactly is this, so H prime is here. And now we know this part is on smaller circle with radius 3. This radius is 6. So smallest circle with radius 3 will be what? Let me draw here. Now, a bit larger. It will be this. So this part will be 3. Okay, and h will be exactly like this. Will be here. Okay, because h prime, and o are collinear. So this one is 90. And because h prime was 90, we said it will be half of this part. So half of this. Now we want to find minimum distance from B to H in this figure. Okay, so if we want to find minimum distance in this figure, we can draw up to this part a tangent line to this, and the rest will be from the circle. Okay, now this tangent point is important, so I draw this one and I say okay, this is 90, this is 3, this is 3, so this part is 6, and this radius is 3. Sorry, here OH is 6, OB 12, so this one is 6. We know OB is 12, so this one is 6, this one is 6. And we can say, okay, this is 12, it is 6. 12 is hypotenuse because it is 90, so this angle is 30. Now we can conclude this angle is 60, so this angle is 30 again. Okay, so this part is what? Is sine 60 times 12, which is 6 root 3. This length is what? Because it is 30, you can say 30 over 360 degree times what? The perimeter of this circle, which is 2 pi r, which is 2 pi times 6, 12 pi. So 330 over 360 is 1 over 12. You can divide both numerator and denominator by 12. So it will be pi. This length is pi. And this length is 6 root 3. So the answer is pi plus 6 root 3. So the answer will be which choice? Choice E. Okay, if you had any question about this or want to solve more problems related to cone and something like this, and 3D geometry, feel free to send message to my WhatsApp number in the description. AMC 12B 2023, problem 22. A real valued function f has the property that for all real numbers a and b, f of a plus b plus f of a minus b equals 2f of a f of b. Which one of the following cannot be the value of f of 1? Okay, when you have function problems like this, or also other function problem, one thing is considering a small example, which also in other problems so much useful. Examples, for example, a0, something like this. Idea 2 special cases, for example, a equals b, something like that. And lots of other cases, 14, 15 important ideas in function. If you want to learn them, as I said before, you can send message to my WhatsApp number. Okay. So here, if you replace, for example, a and b with 0, then 2f of 0 equals 2f of 0 whole squared. Okay, so we can say f of 0 is 0, or if f of 0 is not 0, we can divide both sides by, we can cancel 2 by f of 0, and f of 0 is 1. So let's check. If we consider only a0, b0, okay, then f of a plus f of a equals 2f of a, f of 0, okay? Now, 2f of a equals 2f of a0. If there exists, this sign means there exists x such that f of x is not 0, then you can consider that x equals a, and then f of 0 will be 1. Otherwise, for all x's, f of x should be 0, okay? So we've concluded a better result. And let's check this part. Is it correct? Does it satisfy the equality? This one 0, 0, 0. Okay. So we can reject which choice? Choice A, because f of 1 can be 0. Now let's consider other things. A, let me copy this equation. Okay, for example, here we can consider A equals B. Then f of A plus B equals A plus B will be 2A. That's right. Plus f of 0 equals 2f of a whole squared. Because we want to focus on finding f of 1, we can say, okay, if a equals 1/2 in this part, f of 1, here a equals b equals 1. F of 1/2 times 2, which is f of 1, plus f of 0 will be equal to 2f of 1/2 whole squared. So f of 0 is what? Is 1. And this one is at least 0 because it is a square. So f of 1 is at least -1. Okay, so one necessary condition. So we can select which choice? Choice A. The only choice that is not greater than equal to -1 is choice A. Okay, if you want to find exact function is what and want to solve problem completely, feel free to send message to my WhatsApp number in the description. And also, if you want around 14-15 important ideas, consider is it 1-to-1. Some when we have complicated terms, try to write it twice. Sometimes you should divide, sometimes you should subtract. If you want to learn all those ideas, as I said before, send message to my WhatsApp number. AMC 12B 2023, problem 23. When a standard 6-sided die is rolled n times, the product of the n numbers rolled can be any of 936 possible values. What is n? Okay. For this problem, I want to use casework. Okay. Casework and also small examples. Two important ideas, but before exam, I said the most useful ideas are these two things. Casework, in casework, you should consider the most limited case. Okay, we have n values, and each of them is 1 or 2 or 3 or 4 or 5 or 6. Next one, 1, 2, 3, 4, 5, 6. And so on up to 1, 2, 3, 4, 5, 6. First one, the second one, the nth one. And now, which of these numbers is the most limited one? 5, because we have only one. And the product can be what? 2 to the power of something, for example, 2 to the a, 3 to the b, and 5 to the c. Okay. For example, for 2, 4, 6 are multiples of 2. For 3, 3 and 6. But for 5 only we have 1 5. Okay. So if you determine power of 5, then it determines that how many exactly 5 do we have. Okay. If, for example, you say a is what, you cannot say how many dice are 2. Okay. So let's focus on 5. 5 to the c. C can be what? C can be, for example, n minus 1, n minus 2, 2, 1, and 0. Okay? So when you have n, the power of c is n, so all of them should be 5. So 5 to the n, we have one case. Then when power is n minus 1, 5 to the n minus 1 times something, you have one die, one roll. Next one, 5 to the n minus 2, two rolls. Here 5 to the 1, you have n minus 1 rolls that they are not 5. And here 5 to the 0, you have n rolls that are not 5. Okay, so now in next step, I consider we have m rolls in general. That each roll is 1, 2, 3, 4, or 6. Okay, and then if we calculate this, we can replace these blanks in previous part. Okay, 1, 2, 3, 4, 6. Okay, now let's consider power of 2 or power of 3. Power of 3 is what? So, here, for example, power of 2 or power of 3. Power of 2 can be from what to what? Look, we can have 2 to the 0 if we select from all of them 3 or 1. 2 to the 1 if we select from one of them 2 and from the others, for example, 1. 2 squared, 2 to the n if we select from all of them 2. 2 to the n plus 1, 1 4, and from the other 2. 2 to the n plus 2, 2 fours, and from the other 2 to the 2n. If you select from all of them, 4. Okay, so if it is 2 to the 0, then from all of them, we should select what? 3 or 1. So the power of 3 can be what? 3 to the 0, 3 to the 1, to 3 to the n. If it is 2 to the 1, for example, you can select 2 and from others 1, 3 to the 0, 1, 3, n minus 1, 3, if we select 2 and from others 3, or if we select 6 and from others 3, it will be 2 to the 1 times 3 to the n. Okay, so we can have 3 to the n. If we have 2 squared, okay, so we are considering case works. 2 squared, then you say, okay, 3 to the 0, 3 to the 1, 3 to the n minus 2. We can select, for example, 2 2's, no 3, all of them 1, 2 2's, 1 3, 2 2's, n minus 2 3's, and then if we select 1 2, 1 6, and from the other 3, then we have how many 3's? N minus 1. Okay, 3 to the n minus 1. And if we select 2 6's and from others 3, then it will be 3 to the n. Okay, and we cannot have more than, for the power of 3, more than n. Okay, now we can do the same thing up to 2 to the n. With 3 to the 0, if we don't select 3, all of them 2. If we change 1 2 to 6, it will be 3 to the 1. If we change all 2's to 6's, it will be 3 to the n. Now, 2 to the n plus 1. We should select 1 4, at least 1 4. Okay, then we can have 3 to the 0. For example, 3 to the 0 is 1 when we have 4, all of them 2. If we change 1 2 to 6, it will be 3 to the 1. Because we have n minus 1 6's, we can reach to 3 to the n minus 1. Okay, now with the same approach, you can say if we have 2 to the n plus 2, we have 2 4's and n minus 2 6's. We can change each of these to 6, so we will reach what? 3 to the 0, 3 to the 1, 2, 3 to the n minus 2. And by the same approach, you can go up to 2 to the 2n minus 1, 1, 2, and the others 4, so it will be 3 to the 0, 3 to the 1. And last one, and sorry, here because we have m, we said here we have m2, so we should change all of them to m. Okay, so here m, this one m. Okay, so m minus 2, m plus 2 to m minus 1, 2 to the 2m, 3 to the 0. Okay, so how many cases do we have? If we consider these parts up to here, 2 to the 0 to m, 2 to the m, and each of them has n plus 1 cases, and for the other one, it will be what? It will be 1 plus 2 to m plus 1. 1 plus 2 to, 0 to m minus 1 is m, which will be m times m plus 1. Let me check 1, 2, and we set to this one. M cases, yes, m times m plus 1 over 2. Let me just check this one here. I've selected 0 to m plus 1, each of them m plus 1, m plus 1 squared. Or we can do something. We can select, for example, from, because we've written m times m plus 1, we can consider to 2 to the m minus 1, so it will be 0 to m minus 1. M plus 1, and here will be 0 to m plus 1. Last one will be m plus 1, so it will be m plus 1 times m plus, let me write, m plus 1 times m plus 2 over 2. Okay. So m can be from what to what? Here, in this case, m is what? M is 0. We don't have any choice. M is 1, m is 2. M is n minus 1. M is n. So from m0 to n, m0 to n, it will be what? M times m plus 1 plus m plus 1 times m plus 2 over 2. Okay. So now I want to use, let me check idea 2, idea 3. Idea 3, I want to use hockey stick identity again. Before AMC 1012A 2023, I had released a video, and in that video I set many of these identities. It is what R choose R. Also in AME we have similar problem. If you want to know that, also Van der Mon's identity important. If you want to know them, feel free to send message to my WhatsApp number in the description. R, n choose R, it will be n plus 1 choose R plus 1 here. If we use the same thing, it will be what? We can say it is equal to sigma m equals 0 to n 2 times m plus 1 choose 2 plus this one m plus 2 choose 2. Okay, so if we replace the first one will be 2 times m0. 1 choose 2 is 0. 2 we can start from 2 choose 2. 2 choose 2, 3 choose 2, 2. Last one, if you replace m with n, m plus 1 choose 2. Plus this one. 0 will be 2 choose 2 plus 3 choose 2. 2 n choose 2. Okay? N plus 2. If you replace n with n plus 2 choose 2. Now if you use hockey stick identity, the first one is what? M plus 2 choose 3. Plus this one will be m plus 3 choose 3. Now we know this one equals what? 936. And we want to find n. 936. One way is to check the choices. One way is to calculate. For example, we can say it is what? We can say it is 2 over 6. Let's write n plus 2 times n plus 1 times n over 3 factorial, which is 6, plus n plus 3 times n plus 2 times n plus 1 over 6 equals 936. Okay, now we can factor from n plus 2 times n plus 1, and we can multiply both sides by 6. Okay, so it will be n plus 2 times n plus 1 times 2n, if you factor from that, plus n plus 3 equals 6 times 936. So it will be n plus 1 times n plus 2 times 3n plus 3. 3n plus 3 we can factor from 3 again, it will be n plus 1. equals 6 times 936. We can divide both sides by 3. It will be 2. So n plus 1 squared times n plus 2 equals 2 times 936. Okay. So it is related to cube of, for example, this one approximately. So 936, let's prime factorize this number. Is 4 times, it's multiple of 4. And also is multiple of 9. So let's write first 4. 2 times 4, 8, 13. 3 times 4, 12, 16, 4. So it will be 2 times, 4 times, 9 times, 2 times 9, 18, 54, 6. Okay, so now it's 2 times 4, for example, times, or let's write like this. 2, 2, 2, or I think that part is also okay, 4, 9. Then instead of 26, we multiply, we write as 2 times 13. So 2 times 2, 4, 13. Okay, we should see this what squared times next one. If we consider 4 squared times next one, it will be 5. If we consider, so because we have 13, this number is good. If, for example, 13 is this one, then we need 13 here. If this one equals 13, so this one is what? 2 times 3, 6. 4 times 3, 12 times 12. We can write it like this. Okay, so this one is 12 squared times 13. So we can conclude n plus 2 is 13. And n is what? N is 11. Okay, so we found n. Okay, as you can see here, we've learned how to approach similar problems by using a small example, considering caseworks, and step by step reach the solution. Okay, if you want to solve more problems, especially this approach in AME, use some useful. If you want to solve more problems, feel free to send message to my WhatsApp number in the description. AMC 12B 2023, suppose that A, B, C, and D are positive integers satisfying all of the following relations. A, B, C, D is this, and LCMs are this. Okay, it says what is GCD of A, B, C, D? Now for this part, we should consider caseworks somehow. First, powers focus on prime number 2, then 3, then 5. Okay, so idea 1 is caseworks. And now I consider A, B, C, D. Okay, we have 4 values, A, B, C, D. First, let's focus on, because I want to find GCD, the prime numbers are not related to each other. So I want to see what can I say about powers of 2. Here, max LCM is what you should consider. Select maximum power of each prime. So A has, for example, A is 2 to the power of something, B 2 to the power of something. The maximum one is 3. But here, because B and C is 1, maximum of B and C is 1. So here, B cannot be 3. A is 3. So from here, we can say A is 2 cubed. From here, so we can conclude power of B, C, D are at most, powers of them at most 3. B, C 1, B, D 2. So B cannot be 2 because here B is at most 1. So D is 2. So D is exactly 2 squared. So maximum of B and C will be 1. Now, product of them is what? 2 to the 6. 2 to the 3, 2 to the 2, 2 to the 5. We need 1 2 to the 1 and 1 2 to the 0. Without loss of generality, we can consider this. Because it has no effect on GCD. That which of them is 2 to the 0, which of them 2 to the 1. So we can conclude GCD of ABCD is odd because it selects minimum 1, 2 to the 0. So we can reject A, which is even, and E. Now let's focus on 3. Okay, so here 3 cubed we have for A and C. A and B, 2. So maximum power of A is 2. So A and C when it is 3, C is 3 cubed. So C is 3 cubed. Now, because 3 cubed, B and D, 3 cubed. But A and B, 3 squared. So max B is at most 2. So when here we have 3, D is 3 cubed. Okay. And we know it should be 3 to the 9. For A and B, the maximum is 3 squared. So which of them is 3 squared? Without loss of generality is B, because look, all cases that have A, B, with the other one will be, so here we can see all others are 3 except A and B, and A and B the maximum is 2. So because it is 3 to the 9, 3, 3, 2, 6, 8, 9. So one of them 3 to the 1. And it's not important which of them 3 to the 1, which of them 3 squared, because it has no effect on GCD. So we can conclude GCD is multiple of 3. So on all, it is exactly 3 to the 1. So we can reject which choice? Choice B. Now let's consider the last prime 5. 3, 3, 3, 2, 2, 2. Because here A and B, where is this part? We have 3, 2. Because we have 2 B and C, 2 maximum, A and B 3. So if we consider this one and this one, B at most 2, so A should be 3. A will be 5 cubed. Okay. Now for A, B, C. Okay, BC at most 2, BD at most 2, CD at most 2. So 2 of them should be 2. 5 squared, 5 squared. And how can we calculate the other one? By this one, 5 to the 7. 3 plus 2, 5. 5 plus 2, 7. So the last one, 5 to 0. And it's not important. The order is what? GCD is not multiple of 5. Because it will be 5 to the 0. So it is not D. So the GCD will be equal to 3. If you want to solve similar problems, it is combination of, we can say, combinatorics and number theory. If you want to solve similar problems, feel free to send message to my WhatsApp number in the description. Last problem of AMC 10B and 12B 2023. A regular pentagon with area 1 plus root 5 is printed on paper and cut out. All 5 vertices are folded to the center of the pentagon. For example, center is O, and it is A, B, C, D, and E. All of them are folded to the center of the pentagon, creating a smaller pentagon. What is the area of the new pentagon? Okay. So, the most important part is are folded to the center means what? Okay, this part. If we want to see this, what? A goes to O. Okay, so the new edge that will be created is what? It will be perpendicular bisector of AO. If you imagine or do it on real paper, you will see it happens. The new edge that will be created is what? Let me draw. It is 142, around 144, 72. Okay. So on this part, we have this. Okay. It is for this one. Now let's consider next one, E. So again, we should connect E to O, and okay, if we consider perpendicular bisector 1, perpendicular bisector 4874, it will be around this one, and we can create what? 346 or 164, 64, 74. Okay, it will be a line like this. Next green line. Okay. And it will be created like this. If we do for other 5 for each of them, for example, this one. It will be 156, around 78. Will be something like this, and the angle 55, 145. So it will be like this one, and this part will be what? It will be 153, 70. Let's consider 77. Okay, around this part, and the angle will be what? 130, 40. Okay, it will be something like that. And last one, 147.73 here. And the angle, 17,107. Okay. So the new pentagon is this one. Okay, so for example, you consider A prime, B prime, and sorry, A prime, B prime, C prime, D prime, A prime. Okay, and we know it is like this, this one, this. So the radius of we know that this one by similarity is perpendicular bisector of this side. So, and we know if OA is R, this one is R over 2, this one is R over 2. So if you draw, and O is also the center of A prime, B prime, C prime, D prime, E prime. So I say it is what perpendicular bisector, for example, it is OM. If we consider for ABCDE, if we draw a perpendicular, for example, to this one or any other side, let me draw in an easier one. So if we consider, for example, the center and draw, for example, this part perpendicular bisector from O. So here it is O, it is A, and it is perpendicular bisector. We know, for example, this one is K, this one is R. The angle is what? 180, the formula ideal 1. 180 times n minus 2, sum of the angles, so 180 times 5 minus 2, 3 over 5. It will be 36,108. So this angle will be what? Will be 54. This angle will be what? 36. It is R. So OK is what? Is sine 54 is what? Is OK over R. So OK equals R times sine 54. Okay. Now, here, when I want to get, I know the area of the ABCD because we know A prime, B prime, C prime, D prime, E prime is similar to ABCDE. If we want to find area of ABCDE, we should divide two similar lengths like OM over A prime, B prime, C prime, D prime, E prime. OM over OK squared times area of ABCD. Okay. It is idea 2 ABCDE in similar figures. When you want to find area, it is the ratio squared. OM over OK. OM is what is R over 2. So we can write it as A prime, B prime, C prime, D prime, E prime. OM is R over 2. OK is what? R times sine 54. Whole squared times area of ABCDE. Area of ABCDE is 1 plus root 5. We can cancel R, so it will be 1 over 4 times sine 54 squared times 1 plus root 5. Now we should calculate sine 54 squared. Okay, for this part, we should be able to find sine 54. Let me tell you how to calculate sine 54. I told you 2 ideas. Okay. Idea 3. When you want to find sine 54, you can say sine 90 minus alpha equals cos alpha. And before exam, I said this. So sine 54 is cos what? Cos 36. Okay, we consider angle. The approach is like this. If you want to find, for example, sine 54, you say alpha equals 18 degree. Then we say cos 2x here equals sine 3x. Okay, we can use this also. We can say another thing. We know cos 54 by the same thing equals sine 36. So by the same approach, we can say cos 3x equals sine 2x. Okay, let's use one of them to find sine x. Then we can find, after finding sine x, we can find cos 36 or sine 54. Okay. So another formula we know idea 2 is that sine all idea 3, idea 4. Before exam, I had released a video and I said all the important formulas like this in trigonometry. Sine alpha cos beta plus cos alpha sine beta, idea 5, or cos alpha plus beta, we know is cos alpha cos beta minus sine alpha sine beta. Okay? So if you use these two formulas, cos 3x will be cos x cos 2x minus sine x sine 2x. And here it will be sine 2x, sine 2x. If you use this, it will be 2 sine x cosine x. And we can rewrite it cosine x cosine 2x minus, instead of sine 2x, we write 2 sine x by using identity 4. 2 sine x cosine x equals 2 sine x cosine x. Now, because alpha is 18, we know sine and cosine of alpha positive. Okay, so let's say, for example, this is x. We can divide both sides by sine, no, by cos x. We can divide both sides by cos x. Cos x is positive because x is 18 degrees. Now, cos 2x. For cos 2x, I want to write all of them in terms of sine x because it is 2 sine squared x, 2 sine x. For cos 2x, you can write it if you use this formula and simplify this. Idea 6 sine squared alpha plus cos squared alpha equals 1. If you use identity 5 and 6, we can write this one as 1 minus 2 sine squared x minus, if you had any question, feel free to send message to my WhatsApp number in the description, 2 sine x. Now, if you take all things to right side, it will be 4 sine squared x plus 2 sine x minus 1 equal to 0. If we use quadratic formula, again, before the exam, I said all these things, quadratic formula, and here we want to use that. Sine x is negative 2 plus minus square root of b squared 4 minus 4ac, which is plus 16. Over 2, it will be negative 1 plus minus root 5. Okay, and now, we multiply 2a 2 times 4, 8. So if you divide both numerator and denominator by 2, it will be 4. If it's like minus, sine x will be negative, but we know sine x is positive, so we should say negative 1 plus root 5 over 4. Now I want to find what? Cos 36 or cos 2x. Cos 2x will be what? We know that it is 1 minus 2 sine squared x. So it will be 1 minus 2 times this squared, which will be 1 plus root plus 5, 6 minus 2 root 5 over 16. If we divide this one, it will be 8. It will be 1 minus 3 minus root 5 over 4. If we use common denominator 4, 4 minus 3 is 1 plus root 5. Okay, so cos 2x is 1 plus root 5 over 4. So we've proved that it is equal to 1 plus root 5 over 4. Now, if we replace, it will be 1 over 4 times 1 plus root 5 squared. Let's write it like this. 1 plus root 5 squared over 4 squared, which is 16, times 1 plus root 5. We can cancel these by one of these things, this 4 by this 4. So it will be 4 over 1 plus root 5. Now we should rationalize. We multiply by root 5 minus 1, root 5 minus 1. So it will be 4 times root 5 minus 1. Root 5 squared minus 1 squared is 5 minus 1, 4. So it will be root 5 minus 1. Okay. So the answer will be choice B. Okay, if you want to learn trigonometric formulas like this, I had released many of them before. AMC 10, A12, A2023. If you want to learn other background ideas in combinatorics, algebra, number theory, and geometry, or want to solve more problems like